see this question all the time on like the woodworking forums and things on how to cut aluminum with woodworking tools. The answer is simple. Just like wood. Seriously. Just like wood. The only difference is this will gall up on your woodworking blades because aluminum likes to stick to things. So you want to use something like this stuff, or W40 if you got it laying around. This works a whole hell of a lot better. With Tap Magic and a good sharp carbide blade, just like you just saw, you will get a mirror bright finish in all your cuts. This is 1 inch thick by 10 inch wide aluminum. So this is 60-65. So your sheet stock, things like that, that will still make short work of it. You can also use routers, slow the speed down. Don't run it at 23,000 RPM or whatever top speed is. Slow it way down. Be forewarned, it does throw really hot chips everywhere. So safety glasses, and it'd be smart if you wore like long sleeves and gloves and stuff, but I'm not that intelligent. So anyway, we're cutting these up for fixture plates for our new legacy CNC router. You guys can see that in maybe later in this video. I don't know if we'll get to it before we have to edit this and put it up on the website, but definitely next video. So yeah, that's how you cut aluminum. Just throw new woodworking tools and go. Be warned, if you do have a saw stop like I do with a nifty blade break in it, you will want to put it in bypass mode. So check your user manual on how to do that. If you don't, you will be sans blade and blade break, and it's about $200 to get a new set of those. So anyway, yeah, that's how you do it. Alright, so now that we've got our fly cut so it's nice and flat on one side, we're going to go ahead and drill 0.7 inches using a G83 peg drilling cycle into that plate. And we only want our finished plate size to be 0.6275. So that's going to let us fly cut the other side flat, and while we're fly cutting the other side flat, we'll actually fly cut down past the depth of the hole. That way we don't have to worry about drilling through our plate and hitting our vices or any other fixtures and stuff we're using to make these plates. Make sense? So basically our plate is this thick, like that thick, okay? We're going to drill that deep into the plate, turn the plate over, and then fly cut off that much. Well, that much. Leaving us with a plate that has a hole all the way through. And then we'll probably actually tap these by hand, just because I've never tapped anything on the CNC machine, and I would rather tap them by hand and get them actually tapped than screw it up and break off a tap and ruin a plate and all that good stuff. So yeah. Oh, and then we also have to like chamfer the edges of the hole so the bolts don't get stuck in them and they go in and out easy, because this edge on that hole that drill bit's leaving is kind of like, it's got a burr on it, so we've got to chamfer the edges. I'm sure there's an actual chamfering tool that you're supposed to buy. I'm going to use a countersink that I've already got, and we'll just actually hit it with a countersink just to kind of clear up that burr. And then we've got to actually take, as you guys can see, that back edge is extremely sharp. So one of my minions gets to sit there with a bastard file and break those edges down so that it doesn't do things like that to your hands right there when you pick them up. Oh, or, well, that one's actually better, or something like that. Alright, so we are drilling the last of our, I guess our mounting holes for our fixture plates for our legacy CNC router. We're going to be replacing the MDF base plate with this aluminum plate, which has these 1/4 holes drilled and tapped every ½ inch. So this is going to let us mount all of our fixtures and stuff very easily. And it'll be nice and repeatable, and it won't change thicknesses or sizes with the temperature and humidity like MDF does. So it gives a really accurate cut on our boxes. Right now we're doing a G83 pet drill cycle, and it's going to run through this about 100 times for this section over here. Where you see there, this is where we're drilling now. All these holes here were drilled in the burst operation, but because this plate's bigger than the envelope of the Tormach, we had to slide it over, re-zero, and then do a second machining operation. Alright, so I'm fixing to show you guys Tormach's super fly cutter. This is an awesome fly cutter. Not that I have much experience with one, but I'm extremely happy with this one, considering it's the only one I've ever owned. They have two insert types for this. One is for aluminum, which is the one we're using now, and the other one is for ferrous metals, steels, some of it works for like nickel, titanium, things like that as well. But this is designed for aluminum, and it is like super shiny, polished, bare carbide. This thing makes a ton of chips. Okay, so what we're doing is we are fly cutting the back side of our fixture plates now. We've already drilled the holes all the way through, fly cut the other side, and chamfered all our mounting holes. Now we're going to actually fly cut down to, say right about here. All right, and that will expose the bottom of our holes. That way we did not have to drill through and risk drilling into the vices or figure out how to mount, how to hold this thing and drill all the way through. So we drilled our holes from the other side, and now we're going to fly cut down to our holes. I'm not a machinist, so this is probably not the correct way to do it, but it's the way I came up with. So hopefully it works. Let's give it a shot. That would be what I would call not working at all. Okay, so everything's set back up again. I just spent the past 15 minutes digging through my code to make sure all of our Z coordinates were in the correct direction, because I converted this code over from when I did the other side of the plate, and they were all negative numbers. Now they're all positive because we're going off the bottom of the plate, so we end up with a perfectly sized thickness plate for both plates. So anyway, it's all set up now. I just readjusted the coolant. We should have everything ready to go. I'm going to hit the go button, and then I'm going to go hide, because I don't really trust the boring bar, because I've knocked it off twice. It hadn't come out yet, but I don't want it to come out and like stab me. So I'm going to hit the go button and go hide on the other side of the shop. Now we're taking some metal off. Alright, this is a 50 thou deep cut at 15 inches a minute. According to guys at Tormach, we can actually run at 50 inches a minute, but I'm doing a full step over. We're doing 2.5 inches on the first run, so I'm not going to do 50 inches a minute. We're doing 15 right now. I could easily speed this up on the rest of the pass, but I kind of want to take it slow, just because I don't want to turn anything up like I already have. So. Just throwing chips everywhere.
When this tracks back again, it'll probably pull that.
Stand over here, make sure it's got plenty of slack, dude. There you go. That's a good shot of the coolant right there. things didn't break. Look at that shower of aluminum that's throwing off, dude. Alright, let me go.
Kind of warm, isn't it?
Yeah, we're going to crank the coolant up a little bit. Not too much. Alright, what we're doing now is we're milling the pockets that the boxes are going to sit in. So that bit's going to make like a million passes back and forth. What happens is if you go in that corner, it goes from just being a little bit engaged to being like 90% engaged right there in the corner. And it digs the fit into the metal. Yeah, it doesn't like. Alright. Alright, I'm Charlie, and I make dice. This week we were saying 3, 2, 1. So, that's our legacy CNC box maker. And all of our viewers know that we've been waiting forever to get this thing back online so we can start making boxes to get all these dice shipped. But we finally got to the point where we're making the fixture place to hold the boxes. And this video is going to be all about how to make the cool tools to do things like make boxes. So I just ran all the menus out of the shop because I'm fixing to make our first test cut on our legacy router for our red oak boxes. We're using our new vacuum chuck. This is the first time I've used a vacuum chuck in anger, and we're making a fairly aggressive cut, 1 inch deep, 1 inch wide, and some fairly hard wood. And this is only held in place by air. So I don't really trust it. We're doing something on our Cormax, no big deal, because we've got an enclosure over there. We don't have an enclosure on this machine, and there's no good way to build one for it. At least not that I've figured out yet. So, safety first. Yes! So next time we might need some dust collection. Now it's time to call in the minions for cleanup. So